Hi everyone, welcome to my channel. Today we will discuss about Gauss Seidel iteration method. Okay, first let's see the concept and then we will dive into problems. First, let's see a system of linear equations. Okay, system of linear equations. Let's take a1x plus b1y plus c1z equal to d1. Now a2x plus b2y plus c2z equal to d2, and the last one a3x plus b3y plus c3z equal to d3. So this is a system of linear equations. Now in this system of linear equations we have to find the diagonal element coefficient values. Okay, what we have to find in this system of linear equations, we have to find the diagonal element coefficient values. Diagonal element values. So this is a diagonal element, this is a diagonal element, this is the diagonal element. We have to find the value of x, value of y, value of z. X, y, z. These three values we have to find, which is nothing but this value, these diagonal values we have to find. Okay, how we can find? Let's take this as first equation, second equation, third equation. So in first equation, let's take this equation. First equation, a1x plus b1y plus c1z equal to d1. Okay, let's move this to this side and also this one also this side, so that a1x equal to d1 minus b1y minus c1z. Now let's move a1 also to right side, x equal to 1 by a1 d1 minus b1y minus c1z. Okay, this will be your fourth equation. Why we have done this? Because we have to find a1x, right? For that, in this also we have to find x value mainly. So we just took this equation, we moved all the unwanted variables to right side, hence we will get only x to the left side. Okay, so this will be the value of x. Like way, we have to take second equation, a2x plus b2y plus c2z equal to d2. Okay, so what we need to find in this b2y, we have to find in this also, we have to find y value, right? So let's write like this, we have to move all the unwanted variables to right side, so that y will be left over in the left side. So let's take b2y here only, d2 minus a2x minus c2z. Okay, now let's move b2 also, 1 by b2 d2 minus a2x minus c2z. This will be your y value. Okay, let's take the third equation, a3x plus b3y plus c3z, right, d3. This is our third equation. In this also we have to find c3z, which is z value we have to find. So let's move the unwanted variables to right side, c3z equal to d3 minus a3x minus b3y, and also we have to move the c3 to right side so that z will be left over in the left side. So 1 by c3 d3 minus a3x minus b3y, this will be our z value, right? This is our sixth equation. So let's write all the x, y, z values which we have taken from 4, 5, 6 equations. Okay. So x value will be 1 by a d1 minus b1y minus c1z, which we have find previously, and y also we have found, like 1 by b2, so a1 by d2 minus a2x minus c2z, right? Next z value is here only, z equal to 1 by c3 by d3 minus a3x minus b3y. Okay, so these are the x, y, z values. So, and the next thing we have to see is we use these x, y, z values or formulas to find the values of x, y, z, right? So we have to find like this. So in this Gauss Seidel iteration method, we have to take first initially x, y, z values as 0. We can say as first iteration. For first iteration, we should take x equal to 0, y equal to 0, z equal to 0. Okay. So we can write for first equation, this is the initial equations. For first iteration equations, we will write equations such as x1, y1, z1. Okay, x1 will be 1 by a1 and d1 minus b1. Y value, which one y value we have? This initial y value we have, so we can write y0 and minus 0 means initial y value. Okay, y1 means this one minus c1 z initial, right? This will be our first iteration x1 value. What will be the y1 value? This one only, 1 by b2 d2 minus a2x. What we have to take? Either x equal to 0? No, we have to take the value which we found just before. Okay, x1 value we have to take here, minus c2z. Z value, do we have any z values here? No, we have only this value, so we should take z0, right? I hope you understand. Next, z1. What is the z1? 1 by c3 d3 minus a3x minus b3y. So in this x place, which value we have to take? X equal to 0? No, we have to take the just before the x value which we found, x1 we have to take. Now in place of y, which one we have to take? Y equal to 0? No, we shouldn't take y equal to 0. We should take which is the y value we found just before, y1. You got it? So we just have to take like this. If we have previously x equal to 0, y equal to 0, z equal to 0, this is 0 iteration, right? In first iteration, we have to take in first place we will take x value, y value, z values. In second iteration, these values we have to take. In third iteration, we have to take these second iteration values. Okay, we shouldn't take always these things. For every step, the values will be updated. Hence, we will take just before values. Okay, right. So we have already seen what is Gauss Seidel iteration method, how we are finding x, y, z values like this, and how we are taking for first iteration, second iteration, third iteration. Okay, there is one more rule. Okay, there is one more rule. Before solving the given question, first we have to arrange the given system of linear equation to satisfy diagonal dominance property. Okay, what is this diagonal dominance property? See, let's say we have a1x plus b1y plus c1z equal to d1. In the next equation, a2x plus b2y plus c2z equal to d2. Next, a3x plus b3y plus c3z equal to d3. Okay, this is our system of linear equations. In this, what we have to follow to satisfy this diagonal dominance property? This is nothing but this a1 value. We are finding these, right? So this value should be greater than the sum of these two values, which is nothing but we can say a1 value should always greater than b1 plus c1. It doesn't mean any signs plus or minus, but that's why we used modulus here. Okay, we just have to add up b1 plus c1, then a1 should be greater than this sum. For this also we can say we are finding b2 value, hence b2 should be greater than a2 plus c2, right? Here also you can see here we are finding c3, so c3 value should be greater than a3 plus b3, right? So what we have learned, first thing, how to write x value, y value, z value equations. Second, what we have learned, how to write first iteration equations. Third, what we have learned, diagonal dominance property. Okay, these three we have to keep in mind. Okay, now let's solve one problem by using these three steps so that you will understand clearly. Okay, let's take an example to solve Gauss Seidel iteration method. Okay, so the given equations or system of linear equations will be 2x minus y equal to 7 minus x plus 2y minus z equal to 1 minus y plus 2z equal to 1. First equation, second equation, third equation. So first what we have to check, diagonal dominance property. Second, what we have to check, if it is not there we have to rearrange the equations. Okay, so let's see is this given equation in the diagonal dominance property? 2 should be greater than the sum of y value, z coefficient values. Yeah, 2 is greater than only. Here this b2 should be greater than, we have 2y here, right? 2 is always greater than this sum of these two, and here you can see z coefficient also greater than x and y coefficients, so it is satisfying the diagonal dominance property. So we don't have to rearrange the equations. Okay, let's proceed with the second step. What is the second step? We have to find x, y, z value for first iteration. Okay, let's see how to find first iteration. Let's write these equations again. 2x minus y equal to 7, first equation. Let's keep x left side and remaining unwanted variables to right side. That is nothing but 2x 7 plus y. Now 2 also we have to move, 7 plus y by 2. This will be our x value, initial x value. Let's find y value, minus x plus 2y minus z equal to 1. Okay, this is our second equation which is given in the question, and we have to convert it by keeping left side only y. So it will become 2y equal to 1 plus x plus z. To also move to right side, 1 plus x plus, like this. This will be our fifth equation. We have x value here, and now we have y value here. Let's find z. We have to take third equation for z. It should be minus y plus 2z equal to 1. This will be third equation. Now let's keep z in left side only. Move unwanted variables to right side. Z equal to 1 plus y by 2. This will be your sixth. So from fourth, fifth, sixth, we have x value, y value, z value. Let's write 4, 5, 6 equations. What are those? X equal to 7 plus y by 2. Next, y equal to 1 plus x plus z by 2. Next, 1 plus y by 2. Okay, let's find first iteration. So for first iteration, we have to take x equal to y equal to z equal to 0. We have to take all values as 0 initially. Okay, so let's see x1. x1 equal to 7 plus y by 2. 7 plus y by 2. In this y plus, which one we have to substitute? Which one we have? Just before we have y equal to 0. We don't have any other y values, right? We should take y equal to 0. Then 7 plus 0 by 2. That is 7 by 2. So what will be 7 by 2? It will be 3.5. Okay, this is x1 value. Next, y1. 1 plus x plus 7 by 2. 1 plus x plus 7 by 2. Which x value we have to take here? Just before we found that x value, not the initial one. Okay, so 1 plus 3.5 plus 7 by 2. So what is the value of 1 plus 3.5 plus 7 by 2? You can use calculator. So it will be 2.25. Okay, now let's find z. z1 equal to 1 plus y by 2. y by 2. Here we used y0 because there is no y values. Here x, we used x1 value. Here y, we should use this y1 value, not this initial one. Okay, just before we found, right, that value. So it will be 1 plus 2.25 by 2. Then it will become 1.625. So this is our first iteration values. Let's find second iteration. So previously we found x1, y1, z1 values. So we should take these values to find second iteration. Right? We shouldn't use initial values, but we should use x1, y1, z1 values. Let's find what is the x1 formula we have. So now we have to use x2. x2 equal to 1 by 2 7 plus y1. Okay, so 1 by 2 7 plus y value we have 2.25. so what will be the result of this? 4.625. Same way we have to find y2. y2 we have 1 by 2 1 plus x plus z. Which x value, which z value we have to use? X value just before we found x2 value. Z value, which is the just before value we have? Here we have z1. So we have to use z1 value. So y2 will be 1 by 2 of 1 plus x2 value 4.625 plus z1 value 1.625. Then the result will be 3.625. Okay, and next we have to find z. z2 will be 1 by 2 1 plus y1, because here we have to use y2 because we previously found this y2 value. So what will be the solution? 1 plus 3.625. Okay, then the result will be 2.31, right? So like this we have to find second iteration, third iteration, fourth iteration also. So till when we should stop these iterations? We have to do this till we get the same results for x2, y2, z2. So if we find x3, y3, z3, so I have written here x3, y3, z3, which is nothing but third iteration and also fourth iteration and fifth iteration. You can observe in this sixth iteration, seventh iteration. So I have done till 7 iterations, but you can observe here for sixth iteration and seventh iteration we have got same values, hence we will stop the solution here. So these will be the 7 iterations, and this is all about Gauss Seidel iteration method. Thank you.